welcome to our webinar on how to know when you need an AI expert. Tim, would you like to go to the next slide? Thanks. All right, so I want to introduce our speaker for today. So this is Dr. Tim Oates. He is the co-founder and chief data scientist here at Synaptiq. He has over 20 years of experience in guiding organizations and companies of all sizes in applying AI and machine learning to business problems across industries, and has guided over 100 clients to their data and AI futures with Synaptiq here. He also earned his PhD in computer science from the University of Massachusetts Amherst with a focus in AI and machine learning. And he spent a year as a postdoctoral fellow at the MIT AI Lab. So, Tim, thank you so much for coming to speak with us today.
Okay, thanks. I appreciate it. So I'm going to go back to the title slide here for a second. I will say I'm happy to take questions during if anyone has anything they'd like to talk about. I won't see it because I have to have my slides up, but Malika, you can always help me, interrupt me if somebody has a question that it seems like it would be a good idea to answer. So as Malika said, the title of this is How to Know When You Need an AI Expert. And given the fact that I think of myself as an AI expert, and I'm also helping run a data science company, the talk could be really short and just be, you always need an AI expert. But it turns out it's more subtle than that. And so I'm going to try and, kind of go through the details. I will talk for just a minute about Synaptiq. We do a lot of things at Synaptiq. My wife asked me, well, like, what exactly do you call your company? Sometimes I call it a data science company. Sometimes I say we do AI machine learning consulting. We do all those things. We also do data strategy. A lot of what we do these days revolves around intelligent products. So sort of focusing on the intelligent side of it, because that's the part that I really enjoy, is the AI and the machine learning parts of it, but then also doing product design and user experience and things like that. So we do sort of the whole end of you're trying to make your products more intelligent, and handling that. So the outline, this will be kind of interesting. So it's going to be a little bit of a kind of far-ranging talk. I want to just start talking about the power of knowledge and expertise. I have a few slides on that. It's not very AI-ish. And I'll use a motivating example of my lawn, and you'll understand that in just a minute. Then I'll talk a little bit about kind of corporate knowledge about AI. And when I'll say AI and machine learning, and I'll mean those things, I'll use them kind of interchangeably. I apologize up front. There's sort of different ways that I have seen corporations or companies of all sizes either have or acquire knowledge and deploy it when it comes to using AI internally. So we'll talk about that a little bit. And then I've got this sort of sequence of things of what can go wrong. So if you don't have an expert, if you don't have somebody who sort of deeply understands the field, you can waste time and money. That seems obvious, but again, there's like a little subtlety there. You can wind up with solutions that are suboptimal. We'll dig into the details of that. It's also the case that AI is a very, very fast-moving field, and it is hard to keep up. And that's a double-edged sword that we'll talk about. And then there are just kind of hidden gotchas that are very particular to AI as a field, as a science, but also as a tool that companies use to solve problems that they might have. So we'll sort of dig through all that. And at the end, I have just a final slide with a brief discussion. So knowledge is power. I think everybody's heard that. I actually started digging into it a little bit in preparation for this presentation, and it turns out that it comes from a lot of sources. Actually, the book of Proverbs from a long time ago says, a wise man is strong, a man of knowledge increaseth strength. There's a Persian poet, again from a very long time ago, who said, mighty is the one who has knowledge. And if you sort of like Google it, knowledge is power, it's typically attributed to Sir Francis Bacon in his Meditations, where he said knowledge itself is power. So this idea that knowledge is very powerful has been around for a long time. And I think we all agree that it's true. But what I'd like to do is just kind of dig into it a little bit. And then, as we go through, I'm going to talk a little bit about sort of knowledge and how it plays out in humans. And then we'll sort of move into the role of knowledge or expertise in particular in AI systems. So here's a true story about my lawn. Now, it is the case that that is not my lawn. That's not my house. I'm also going to bring my neighbor into this, and that's not his lawn or his house. But It's just a visual to help you anchor on it. So uh, my lawn and my neighbor's lawn, the guy across the street from me, neither of them look good. And, bald spots, all the weeds, right? All the stuff that can go wrong with lawns. And I wanted my lawn to look like the one on the right. So my neighbor and I, unbeknownst to each other, took two very different paths to successfully getting to better lawns. And so what I did was I pulled out my credit card, I called a local lawn company and I gave it to them and said, I want my lawn to look good. And essentially, what I was doing was I was buying expertise. So they do this all the time. That's all they do. They know exactly what they're doing. Super easy for me. The whole transaction, sort of like looking up who am I going to call, making the phone call, them calling me back, handing over the cash, took maybe a half an hour of my life. And today, my lawn looks great. My neighbor, on the other hand, took a very, very different route. So he wanted to dig in and understand. So he started Googling and talking to Chat GPT. There was a local agricultural extension that he talked to. There's a university nearby that has some agricultural sort of lawn experts there. Goes to Home Depot, buys a bunch of equipment. That should say weeks of work, not week of work. But basically, what he did was he sort of skilled himself up on lawn care and went through this complete reboot. So he literally killed his lawn, so poisoned it, and then started from scratch. And his lawn looks every bit as good as mine, might actually look a little bit better, right? So what he did, I invested money and saved time. He invested time and saved money. The difference is, and it's interesting because this is going to play out when we talk about sources of corporate knowledge, is that if I want to make another lawn look better, I got to break out the credit card again. He now has that knowledge, and if he has a friend who's got a lawn that looks like a mess, he can help that friend out, right? So he does not know as much as the people that I hired, but the end effect was kind of largely the same. And like I said, we'll kind of dig into how that applies in AI in particular. So so what I said was essentially you can get knowledge in a couple of ways. You can pay for it, or you can try and acquire it. And so famously, Malcolm Gladwell talked about this 10,000 hours, right? So it takes 10,000 hours of practice to become really, really good, to become expert at something. Turns out that actually goes back to a study by Anders Ericsson, who looked at practice among violinists and found that it took about 10,000 hours, right? And he's sort of backtracked on that a little bit and said that's an average. It's not sort of like this threshold that once you hit 10,001 hours, boom. And it's also the case that the quality of the practice matters. But in any event, the sort of the seed of truth there is that it takes time. And so the question that we want to dig into a little bit today is, if you're sitting out there and you're at a company and you see value in AI, do you have the time to spend those 10,000 hours or whatever whatever it will take internally, or are your competitors eating your lunch while you are trying to skill somebody up inside? Like, do you have time to invest? And often the answer is no, but sometimes the answer is actually, yeah, it makes sense for us, and we'll talk about that. So, how are experts different from novices? There are these great old experiments, and I actually did a seminar when I was in graduate school where we played this out. So it turns out that if you get a chess grandmaster or somebody's really, really good at chess, and me, or someone who doesn't play chess regularly, and you go, we're going to show you a chessboard configuration. You get to look at it for, I don't know, 15, 20 seconds, and then we're going to cover it. And your goal is to recreate that configuration. People who are very, very good at chess can do that easily. You and I look at it and we start trying to memorize individual pieces, and we fail at it. And the reason is that people who are very experienced in a domain build chunks, right? So a chess expert looks at that and goes, oh, there's this thing going on, and this part of the board they're doing this, and this part of the board they're doing this thing, and I just need to create those two things over here, as opposed to you and I looking at it and going, I don't know, there's like 18 pieces on the board, and I remember where two of them were. So you get this sort of, they have more structured and connected information. It also turns out, interestingly enough, just as a sidebar, if you take pieces and put them on a chessboard randomly, not as if a game had been played, then the expert and you and I all perform it about the same, right? Because they can't chunk it, right? They can't go, oh, it's this and this. They go, oh, it's 18 pieces, and they make no sense. So knowledge organization and the ability to sort of work with it effectively is better. They also get deep understanding. So we've got these two pictures over here of somebody throwing a football and kicking a football. Everybody, when you took physics, I don't know, in college or high school or whatever, there are all these problems about somebody throws a ball or they kick a ball or somebody shoots a bullet off of a cliff at this angle and how far does it go and how long is it in the air and things like that. So you and I, if we're not experts, sort of look at that and kind of really focus on the surface details. And it's like, oh, it's a kick. Is that important? Whereas an expert just doesn't get distracted by the surface structure and they focus on the underlying principles and patterns, right? So, and it makes it easier to generalize to new problems. And then finally, there's this notion of automaticity. So experts tend to solve problems with minimal conscious effort. You can think about a concert pianist who can play a really hard piece of music um, and sort of not actively engage their brain too much in it, right? It's almost like their fingers have memorized what's going on. But if you've ever tried to learn to play a musical instrument, it's so hard because you have to think about everything that you're doing. Other advantages of expertise: experts solve problems faster. Again, they focus on the conceptual core and they sort of see patterns. They can reason forward and backward, right? So novices tend to look and say, I'm going to focus on the solution. How do I get there? Whereas experts can say, well, what's my starting point? Let me kind of think about good places that I could go. Experts have a reduced cognitive load, again, because they can sort of chunk things. It's not 18 chess pieces, it's sort of two configurations that are overlapping. They have selective attention, they know what to pay attention to. And they can be sort of more creative. So they have these schemas, they can flexibly apply foundational knowledge, and they have this intuition, which lets them make quick and effective decisions without having to think too long. So, okay, so everybody's on board. Expertise is good. I'd like to sort of think about how expertise occurs in sort of corporate settings, and there are kind of three things that I've seen by talking to a few hundred either clients or potential clients or in sort of other contexts. So some say, look, I'm going to focus on my core business. So these are typically like not tech heavy industries. They've got some problem and they think, I think AI could solve that. But that's it, right? If you can solve that problem, I'm very happy. I want that pain to go away. And what they do is they typically hire a consultant to do it. So some actual examples of this that we've done is we came across a company that works with casinos in Las Vegas. And I don't go to casinos much, but at the table when you play, they sort of like swipe the chips over into a little box on the side and the chips drop in. What they wanted to do was to build a system to recognize the denomination of the chip based on a camera that was embedded in that box. So they would do automatic counting of what the sort of the value of the chips were in the box. So that was it. That's what they wanted to do. We did the project. It was very successful. They didn't come back to us, right? Because they didn't have a need to. I also personally did a project on reading scorecards from archery competitions. So it turns out there's like this little bubble form that as you're sort of going around shooting your arrows, you sort of score it yourself. And they wanted to have a phone where you would go, okay, I'm going to take a picture of my scorecard. Let me use machine vision to automatically extract the relevant fields, right? So again, that's it. That's all they needed to do. So, we see this case and we've certainly worked with people like that in the past. Then there's companies that have like some entry level data scientists. So they've got maybe a small team, a couple of people, but they're relatively new to the position. And so we see this in kind of companies of all sizes. Again, they tend to be sort of not super tech heavy, but they see AI and their data as a value that they can where they can extract from their data. So typically there's an internal executive advocate, somebody who says, yeah, like I really think this is going to be good for us as a company. There's also usually a tech enthusiast or two inside who's super excited about working on it, but then maybe the broader exec team needs some evidence. And some examples there that we've worked on exactly this solution played out with a very large, it was $1 billion company, very successful in kind of a boring industry. But they had this giant accounts receivable backlog. And so, because they had lots of kind of small customers. And so, what they wanted to do was look at their accounts, try and train a model that would predict if I called that person, do I think that on that call we could kind of clear up whatever was holding them back from paying their bill? Had a executive, just like I said, that was an advocate for it. There was a guy on board who was really excited about machine learning. And so what we did was we worked with him. The guy in the company did a ton of the work. We provided guidance, helped build a few models. He would take them over, and they did this like really very well designed kind of A/B test and saw that there was a lot of value to it. And the exec inside the company like became a hero, right? Because he sort of brought AI into the company. So great sort of example of that. And then, we've also done work with very experienced AI and data teams. So typically sort of a medium to large company, past success with AI, right? They know that it's important and they've got an existing team that has a lot of expertise on it. But the problem is that there's too much to do. So there's like fire hose over there on the left, which is just, I've got a ton of stuff that I've got to get done with either AI or machine learning. Or what's typically more common for us is we might have some expertise at Synaptiq in an area that they don't. And they say, hey, what we'd like you to do is to kind of like jumpstart that effort. We're going to bring you in, build a thing, we'll take it over and sort of move on, right? So, examples of that we've done are customer-facing chatbots, where an organization just wanted to build their expertise with large language models, and then also a recommender system for training materials. So, lots of ways in which expertise can exist within a company. So, let's talk for a little bit about what could go wrong without an expert. Turns out you can waste time. So AI, so what I would say is that deploying AI solutions is an iterative art. So, and it's not wholly different from software engineering, but there are some important differences. So when I think about software engineering, you say, okay, here's a set of features that we want to get into the product. Let's, break those down. We're going to be agile about it. We're going to have stories and we're going to put things into the backlog and we're going to assign sizes to them. And engineers are going to take an item from the backlog and they're going to spend 2 weeks on it. And then we've got tests that are going to tell us whether it's working or not. And boom, right? We can kind of plow through the backlog. So the problem is that AI tends to be a more iterative thing. So, on this slide, we've got a picture, there's some data pre-processing, and then typically there's using that data to build an AI system. In machine learning, you call it training a model, choosing the kind of model. Then you got to evaluate it and see how well it's doing. It might not be doing well enough. Let's go back and gather some more data. And eventually, we might deploy it, and then the users start using it, and the users start complaining about certain things. It's like great here, but it's not as good here. Let's go back and get some more data. Maybe we need to tweak the model. And so it's the case that, and we'll talk more about this in just a second, is that you have lots of decisions you have to make that you have to gather information on, right? It's impossible. And there are actually theorems in machine learning that says it's essentially impossible to know upfront which kind of model is going to be best. You can have intuitions about it, but it's real hard. So, we've had a few companies say, "Hey, Synaptiq, we had a company before, and it was clear that they were learning on the job, right? So it was a AI consultancy, not unlike ours." But basically they said, yeah, we do AI. And like, we don't really know that thing, but like, yeah, we can do that. And so, they wind up asking Chat GPT, watching YouTube tutorials, reading Stack Overflow posts. Now I do all these things, right? So I I don't talk to Chat GPT too much. Well, actually, so Stack Overflow is my main go-to, right? But you have questions and they need to be answered. But the problem is that if you're learning while doing, you're asking fundamental low-level questions as opposed to, oh, I can't remember the syntax of this particular thing, or what does this parameter do? And so you waste a lot of time doing that. We've also, so despite the fact that I'm an academic, I hear people say bad things about academics all the time, especially in industry. So I've heard this a lot. Yeah, we hired an academic and it just didn't go well, right? And so typically they claim that the academic is trying to solve the interesting part of the problem and doesn't really have the ability to productionalize, which is hard. Not all academics, right? But the point here is that there's sort of, you've got to have somebody who knows what they're doing, but also who has the capacity to deploy things and sort of make it run in the environment that you care about. And getting both of those skills from any place can be challenging sometimes. So let's think then about wasted money. And it's just more complicated than, time equals money, right? So if you're wasting time, you're wasting money. But here's like this just wonderful plot going back to the sort of 80s and 90s of systems that were developed in AI. Alvin, super old system. It's autonomous land vehicle in a neural network. It's the earliest paper I can think of that was doing self-driving using this very simple neural network, not deep, shallow neural network to sort of control a car. You got systems that learn to play backgammon. You've got early networks for doing machine vision, but then what happens is so for a number of years, you were getting this kind of 24-month doubling of, how many petaflops per second days you need to train these systems. And then when we've got generative AI, right? So you've got things like AlphaGo and GPT. There's a thing called neural architecture search. There's a whole bunch of stuff going on in there that now we're getting this 4-month doubling. This is for training time, but what that says is that these models are getting bigger and bigger and bigger. And the bigger the model, the more expensive it's going to be for you to do stuff with it generally, right? And so here's a real simple example, and these are issues that we've run into. So um, here we've got what's called retrieval augmented generation. So I got a chat bot, I've got a human user sitting over here, and I got a bunch of documents. So, maybe I've got people doing maintenance on airplanes, and I've got a whole bunch of manuals. And what I'd like my maintenance techs to be able to quickly get questions answered. And so what that involves is taking those documents, kind of ripping them into pieces, putting them into a special kind of database called a vector store, and then letting a large language model like ChatGPT sort of pull stuff out and go, oh, you asked this question. Here's some pieces that I think are relevant given your question and the chunks of information I pulled out. I'm going to try and answer it. So, but even in that kind of very simple framework, there are ways that you can waste money. So, am I going to pay for local hosting of an LLM? That is, am I going to run the large language model on my hardware? Am I going to run it in the cloud? Or am I just going to let use OpenAI systems and I'm going to pay for API access? Also, some things can happen. So, like the default would be if you don't really know what you're doing, is to say, all right, I'm going to use GPT 401 or I'm going to use O1, the latest model. I'm going to use that for everything because it's the best model. But it turns out that there's some kind of things that you can use cheaper, faster models for to speed things up and to save money. So, if I'm doing airplane maintenance, I sort of don't want to pass along questions about what a good brownie recipe might look like, right? Or maybe I don't want the LLM to get frustrated and start swearing at the technician, which is thing that used to happen. So there are ways that you can use faster, cheaper models to do part of the work and save money. Also, this sort of process of shoving the data into a vector store involves making some decisions. And, if you're not good at doing that, you can wind up going, we really should have used embeddings of size 512 instead of 256. So we made a mistake. Now we got to re-embed everything. And so again, you're spending compute doing that. And then also you have to sort of think about, well, I'm using this large language model now, but what if I want the one that comes out 6 months from now, and then another one 8 months after that? You have to think about how you're building the system using things like Amazon's Bedrock that make it easy just to like pop new models in and nothing else changes. You code it yourself, then things could go sideways on you where you're trying to essentially generalize your code. Then, like a significant problem, I think, with not being an expert is just finding suboptimal solutions. So, in AI and machine learning, in a lot of areas, I think there's a trade-off between generality and power. So, if I have a very general thing, It applies to AI tools and algorithms. Typically, that tool or that algorithm will be good for lots of things, but it is not really, really good at any one thing, right? So, um, jack of all trades, master of none, I guess is the saying there. So, when you tackle a problem, you have to say, well, am I going to take an off-the-shelf approach? Is that going to work well? I can grab this tool. That's probably going to be faster and easier. It exists. Like people use it all the time, but it might not work as well for my problem. So I can get there faster, but I might not get the performance that I need. Or do I want to make a custom solution? So it's probably going to be more expensive because it's going to require some customization, but then the results that I'm going to get out of that are going to be potentially more powerful. And so just like making those decisions can be very hard. And it's compounded by the fact that there are just innumerable algorithms and tools out there, right? So there are random forests and support vector machines and neural networks of a variety of kinds, and there's boosted regression trees and linear regression, right? So algorithms all over the place. Many of the algorithms solve basically the same problems, and they can be implemented in lots of tools. So, am I going to use PyTorch or am I going to use TensorFlow? They do the same thing, but they do it differently, right? They're both sort of deep learning packages that allow you to do lots of stuff. Am I going to use OpenAI or am I going to use an open source Hugging Face LLM, for example? So the lots of decisions to make, and there's interactions between those things, right? So even if you're choosing random forests, maybe this implementation is better than that implementation over there. And you also have to think about, as you're sort of putting these pieces together, how maintainable is the system going to be? How understandable is it going to be? What's the long-term cost of just kind of keeping this thing up and running and servicing user requests? What's the performance in terms of sort of compute, right? Like how responsive, how much latency is there, or how accurate is it? And so, if non-expert, it's like, okay, great. I'm going to grab a support vector machine and I'm going to use the scikit-learn implementation of it. And I'm not going to do any hyperparameter tuning, and I'm getting 87% accuracy, and that seems good, right? But it might be that if you went a little bit deeper on any of those decisions, you can sort of boost it up and get higher accuracy and better return on investment. Okay, there's also the fact that the AI landscape is changing very rapidly. So this is a plot from a Nature article that shows papers that are being published on arXiv. So arXiv is an online repository of papers on lots of topics. And so you can write a paper, I can write a paper, we can post it on arXiv. You got to jump through a couple of hoops, but it's okay. So nothing on arXiv is peer reviewed. Turns out that a lot of papers appear on arXiv and then they wind up appearing in peer reviewed conferences. And I'm not claiming that anybody needs to go and read papers on arXiv, but I think the point that I want to make is if you look at the number of papers submitted to arXiv per month in just AI and machine learning, like we're just kind of grinding along here. This is actually sort of, I went to graduate school in 1993, right? So a trickle, a trickle, a trickle, and then boom, you get this exponential explosion. So what that means is a couple of things I'll talk about in a second. The other sort of graph that's kind of interesting is this history of ChatGPT, where, 2018, 2019, 2020, we've got the GPTs 1, 2, and 3, and people are going, wow, like that's amazing. I did that. That's an incredible achievement. But then boom, it just takes off. So ChatGPT has 100 million users. There's an API. There's ChatGPT 4. It's being placed in mobile devices. It integrates, so now you can do language and vision together. I don't know. Sam Altman was removed and reappointed as CEO. People are freaking about artificial general intelligence. So we've gone from wow, really interesting to wow, we think we have artificially generally intelligent machines, and over a span of I don't know 4 or 5 years. So things are happening quickly. And so what that can lead to is a couple of things. It can be missed opportunities. Um, it could be that your problem was solved 2 months ago. There's a GitHub repo. Somebody wrote a paper. There's a GitHub repo. The implementation is amazing, but your team just doesn't know it exists because of the flood of advances in AI. And then you spend time working on some old approach, modifying it to make it work, right? And again, I'm not suggesting that anybody needs to go, to archive and search for, has anybody solved my problem? I'm just trying to make the point that things change quickly. It's also the case, and we saw this actually happen with a client where there were sort of 2 or 3 papers published that claimed to solve their problem. They had this very sort of niche problem. They all had GitHub repos. They were like, yeah, we'd like you guys to help us explore those things. Turned out that the code was trash, not the company's code, but the GitHub repos. The code was trash. And so we had data scientists working internally to kind of get that code to run on their data, and the results were bad, right? And the problem they were bad is because that the systems were implemented and they used a certain kind of data, and the data that the company wanted to use was somewhat different, and so there were just a mismatch in the results. And so, in that case, you'd be better off building a solution from scratch. It's good to know, right? Like you kind of had to go through the exercise, but both of these things can happen. There's just a bunch of shiny stuff you can chase after. You have to be able to evaluate that carefully, but you also kind of have to keep your ear to the ground to understand what's going on. So, how about a few hidden gotchas? The one is bias in machine learning. So, the basic idea there is that you collect data. Data is often collected by people with the help of machines, for example, and the data collected might have biases in it. So here's one like great example from 2018 where Amazon built a system to essentially evaluate people who are applying for jobs. You can go Google this thing and find all kinds of articles on it. And so what they do is they just passed a bunch of resumes in. Here's a bunch of people that have applied for jobs at Amazon. I'm going to train up a machine learning system to say, would that person ultimately be hired or not? And it turns out that it discriminated against women, right? So what it would do is, if you had a female sounding name, if you went to a women's college, if you used pronouns that were feminine, right, then it would significantly downgrade the score that it assigned to you, indicating unlikely that you'd be hired. Now, the reason it did that was because it tended to be a male-dominated field, and Amazon had hired lots of men through time. And so basically, of all the resumes that come in, it's the guys that tended to get hired, and it was just perpetuating that. So have to be careful about that. Even in machine vision, it's well known that face recognition algorithms tend to perform differently depending on the ethnicity of the person, because it turns out that the data sets that are used to train them up tend to be overrepresentative of certain ethnicities and underrepresented of others. So um, again, I'm not saying that your system that you might build on your own is going to discriminate against, women or ethnic minorities, but it's the kind of thing that you have to think about, right? Like does my data have some crazy skewed collection bias built into it that's going to harm the accuracy of my system? There's also a couple of kinds of drift. So um, not unusual for you to develop a system and go, okay, great, we're getting this level of accuracy. That's exactly what we need. And then what happens is you just go, okay, deployed, we're good to go. And the accuracy starts to degrade through time, but you don't know about it unless you're monitoring for it. So that can happen when the data used to build the system is different than the data that is presented to it when users are interacting with the system. So, maybe you've got a customer facing chatbot and you do a new product release, and now the questions that it's asking are about that product, and there are sort of issues with that product that they ask about a lot, but that wasn't really representative in the data that you had when you built the system. In sales, it might be that you didn't account for seasonality, or we've seen this before, that you have to account for marketing spend, right? So how much money are we spending on marketing? That's an influence. That's a factor that needs to be taken into account. There's also, and this is a bit more pernicious, infrastructure drift. So you can deploy a model and you're running in the cloud and some package there gets updated. There's some new operating system, or a machine learning tool version changes, or there's a subtle change in the data storage format. And so often that will lead to things just breaking and dying, but then sometimes you get these subtle changes where bit rot sets in and your model just doesn't perform quite as well because things have subtly changed internally that you don't know about. So again, very important to pay attention to those kinds of issues when you're developing models, either with an expert or without. And then the last, I think it's the last hidden gotcha I'll talk about is not enough data. So again, so this is the kind of thing where someone who's new to the field would go, okay, great, we got this data. We're going to train up a few models on it. We're going to pump that into an AI system. Results aren't great. So, but the data is all we've got. And so what I'm going to do is I'm just going to pound really hard on looking at other ways of processing the data or different models or different parameterizations of the model. And, like just nothing works. And so I actually did another webinar on this. Turns out that there are lots of things that you can do. So there are lots and lots of methods you can apply when you don't have a lot of data. And again, there's sort of an intuition for the kind of top three categories. We could do A, B, or C. Which one looks like it's possible in this setting? Okay, right. Looks like option B is a good one based on talking to you. Now, given option B, what are the ways in which we're going to operationalize that, right? What are some things that we can do? So there's a link to it. If you hadn't had enough of me today, you can always go click on that link and see what's going on. So, okay. So final thoughts, and my timing is perfect. So, so what's the bottom line? I think the bottom line is that AI as a field, it's very fast moving. So again, in my role as an academic, I have PhD students who come to me and go, they're sort of almost scared to start a new research topic because they feel like there's going to be a paper that comes out on archive in 2 weeks that solves that problem. And I've seen it happen, right? Like I'm working on this thing and oh, boom, 2 papers appeared last week about it. So it moves really quickly. It's complicated. So there are a lot of parts to it. There's data science, data engineering, AI, machine learning ops, sort of all of that comes together. And it's also a bit of an art, right? So I try to convey that it requires a certain sort of level of kind of creativity and problem solving. Um, and that's not saying that software engineering doesn't require that. I think what I'm saying is that it is often the case that you don't know how things are going to work until you try it, right? Like, I don't know if a logistic regression model is going to be better or a multi-layer perceptron. It's just impossible to predict until you give it a shot, right? Um, you can learn while doing. That's a viable thing. It's probably going to take longer to get done. It's probably going to be a little more expensive because it's going to take longer. It's probably not going to work as well as if you have an expert who's working on it. And there may be some of these kind of hidden surprises, these gotchas down the road if you don't think about those up front. Now, what I would say though is you just have to be deliberate about it. So it might be that that's exactly right for you. Again, this company that we worked with on their accounts receivables, they had a very deliberate strategy. What they wanted to do was they wanted to do two things. They wanted to establish the utility of AI in a very non-tech industry, and they wanted to build up some internal skills there. And so they said, we're going to learn while doing. You're going to kind of help us avoid some of the pitfalls. And then once that's done, we feel like we can kind of start doing it internally, right? So the point is like just be deliberate and think about what you're doing. So hold on, give me 2 more slides. So along these lines, actually, at Synaptiq, we've got this thing we call AIQ. It lets you sort of assess your AI readiness. It's a very simple form that you can fill out. You can say, hey, I'm in a company. I'm going to answer a few questions about it. Turns out in working with companies for a very long time, we've identified kind of 11 aspects of organizations that are indicative of their readiness to be able to successfully deploy AI solutions. And you can click the link. There's a QR code. Actually, I believe that Malika is going to send this out as part of the post-webinar follow-up. So, you can look at it later, but you can just fill it out, complete it, and you'll get an assessment, a report that's tailored to your organization's profile, basically. So, okay. Okay, that's the end of my presentation. I really appreciate you listening, and I'm happy to take any questions. And it would be great, Malika, if you could kind of help me navigate the questions.
Absolutely happy to do that, Tim. All right, let's do this. All right, looks like we just got a question in. All right, nope, that was a technical question. So just to echo what Tim said, it looks like an attendee was curious about whether they'd receive the slides and whether they could receive the link to the webinar Tim mentioned. I just posted those in the chat along with the AIQ link as well. And as Tim just mentioned, we'll be sending out a post-event email this week as well that will include the recording to this webinar, the link to AIQ, and a few other relevant links, including to the slides as well, so you can go back and review what Tim presented for us today. But we do have a few minutes here, so if there are any other questions relating to either technical aspects or Tim's content, we'd love to answer those live. If you take a look at the chat as well, though, for anyone who's not comfortable asking questions live, or if you think of it later on, we have an email that we'd want to direct you to send those questions to so we can still get back to you in a short order. It's also on this slide. It's the asktim@synaptiq.ai email right there. So,
Oh yeah, check it out. That's a good email.
all right, it looks like we just got in a question. So, Tim, here's a question for you. Has Synaptiq worked with AI tech stacks coupled with text-to-speech models? If so, what are those models? And finally, do you have any offline TTS models?
So I'm going to say we have not done text to speech. That is not an area that we have worked on. Rather than try and make stuff up, I will say no. I hear people that talk about those things. I think Google's tools are good. I've heard good things about Whisper. I would start out actually there. I mean, it depends again on what your expectations are. I think starting out with one of the big companies' tools, sort of an Amazon or a Google, is a good way to find out what the baseline performance is. It's sort of like starting out with ChatGPT, o1, and then looking at open source models. You can understand how much you're giving up.
Great. Thanks for that answer, Tim.
Mhm.
Let's see. Any other questions live here? Please feel free. No question is too big or small. We're happy to answer anything that you have. Okay, looks like we just got another one in. What was the most difficult solution that Synaptiq has ever worked on, Tim?
Okay. There's a lot. I will say, I'll talk about one project that I thought was particularly challenging. So we worked with a company that was doing automated license plate recognition. And so what they do is they have these embedded systems. They take a box and they put it on a pole. And so there's a camera looking at the road, and what they have to be able to do is identify cars. When they identify a car, identify the license plate. Once they found the license plate, read the plate, right? So look at what the characters are that are there. They were using kind of older technology. This was, we did this a number of years ago. And so they felt that they needed to catch up with their competitors. And so this was prior to the latest advancements with kind of language vision models, which we would probably use if we were going to do it today. Well, except for the fact it's got to run on a pole sitting next to a road. So the reason that was hard was the standard things that make it difficult in the real world. So you've got these cars are flying by, day and night, weather conditions, lots of variation. Who knew that there was so much variation in the license plates across states? And so we had to go through this very long process of, for example, scraping examples of license plate images by using Google queries, license plate Nevada, license plate North Carolina, license plate Minnesota, gathering examples. And then we had to go through a big exercise in data augmentation, which was kind of creating our own license plates to look like those. And then it got even more complicated because the best models were too big to run on the embedded hardware. And so we had to play around with some of Intel's open source tool. There's one called OpenVINO that we were using at the time to try and compress the model, make it run locally, and make it run fast. So it was just this whole thing of hard machine vision problem, sparsity of data, constraints on the compute, and the models were kind of getting bigger and bigger at that time. So very successful. I mean, I will say that that's been a great client. They've come back to us a number of times to do other projects, but That one was challenging. I can talk about others, but I think that one was just lots of obstacles in that project.
Gotcha. Thanks for that, Tim. All right. Any other questions, everyone? We've still got a few minutes. Oh, it looks like we've got a comment, I think, Tim. I'm not sure if you can see it. I'll share it with you afterwards if that's the case.
Okay.
All right, it looks like there is one more follow-up question though. Is Synaptic interested in working with a mixed juncture of AI and robotics sometime in the future? Which is a little different.
Oh, sure. I mean, my research past, I did work with robotics, and I've taught robotics at the university. We have certainly talked to clients, potential clients, that are looking at robotic solutions. There was one that was, oh, I can't remember the term for it, but it was basically agriculture where you have plants that are stacked vertically. It might have even been vertical farming. I can't remember, right? But the idea was that instead of spreading out horizontally, you spread up vertically. And so you've got essentially shelves of plants that are growing. And so um, there was an application there in robotics and sort of inspecting the health of the plants, which was interesting. We did a project though with a company that was in the VR AR space, and essentially the product that they were trying to develop was training tools for surgeons. And so the idea was that in VR or AR, you would hold an instrument that had a tip on it, and then you would perform surgery virtually, and they wanted to be able to track the location of the tip so they could see what was going on. And so that was a lot of sort of cameras and viewpoints and perspectives and tracking things, and that sort of got closer to robotics. So again, we've had plenty of conversations with company space, but the sort of applications we've and have been a bit tangential.